All right. Well, one of my colleagues a long time ago commented about thermology of entering. You don't find that in a dictionary, at least I couldn't, but it really is, kind of the study of heat in wintering, and that's, I thought, was a good idea. So go ahead. The honeybee is really a tropical animal, and it really is adapted to the temperate region by clustering, and we'll go into that. The center of the cluster is really a tropical temperature. Today it's probably only 85 in the middle of that cluster, but the humidity is 60%, and that's pretty tropical. And, okay. The clustering temperature is given at 57. It's probably close in that range, 55, 57, when they start to huddle together to conserve heat. That's actually pretty high, but that's when they start keeping that nest, the center of the nest at least, warm. Okay. The cluster will have a dense outer shell, and I'll show you that, where they try to limit the dissipation of the heat from that cluster. And that's generally about 45 degrees, give or take a little. The bees, outer bees, are essentially go into torpor. It's where they using very, very little energy, and they get the heat from the core as it goes out through that outer shell, and keeps them at that temperature. The bees at the outer shell will die off and sometimes drop to the floor of the hive, and you know that in the spring when you see all those dead bees on the bottom board. That's what's happened. And this is your physics from high school. The smaller the sphere, the less surface area you have, and so that's why that cluster, when it gets cold like today, gets really pretty small, because it has less surface areas to dissipate that heat off of. Okay. Good, yep. That core temperature that is maintained by muscle flexing. It's really shivering, if you wish. They just kind of vibrate their wing muscles and just generate heat. And of course, they have to eat honey to do that, and we'll get to that. But that center core is usually the younger bees, but it's not entirely so. And they just shiver and generate heat. And that core temperature will be 95 when there's brood temperature, with brood present. So today it's probably not 95. It's probably in the mid to high 80s. But as soon as brood rearing starts here, about the first of the year, that temperature will be 95. And it will maintain that temperature until October, when they stop brood rearing again. Now, that core, say today, may be only the size of a silver dollar that's maintained at 95. I mean, if there was brood. And as the temperature outside gets warmer, the bees are able to maintain a larger and larger core. Okay. I went out to the bee yard, this is many years ago, at Michigan State, and the bees were clustered, and I gave them a little puff of smoke. Actually, I was going to put a pollen patty on this colony, so I gave them a little puff. And you can see now the outer core. See, they're not as mobile, and so they had to maintain their position, or they didn't have to. They just maintained their position. These bees here that were warmer, they moved down with the smoke, and you can see that spherical shape of a cluster. Okay, so you take honey plus a bee, and that equals heat plus water plus carbon dioxide. And that's the biology of sugar metabolism. If you look at, this says really the honey per bee is less with larger clusters. And I show you that. This is from a data set of Free and Simpson's many, many years ago, and my copying didn't do real well. But these were hives from a very small number up to about 30,000 bees in the fall. And this is the pounds of honey eaten per 1,000 bees, okay? And I actually put this line in here. It's probably not real accurate, but it was to give you some indication of the shape of that curve. But basically, it says that the more bees, the less honey per bee you use. Okay, another thing you want to remember, heat rises, okay? And that's important for this whole cluster concept, all right? And water vapor rises, but then may condense. It's depending on the temperature. That's important. And carbon dioxide basically sinks to the hive bottom, and if you have a screen bottom board or open entrance, it'll just flow out. But it is important for people that have, say, the wintering houses. That was one of the real problems that they had to solve, was to get rid of the carbon dioxide in wintering houses. It was killing their bees, so they just learned how to scrub it out. Okay, let's look at a fictitious little tree hive. I had a phone call this afternoon down near southeastern Michigan. A tree fell over in a swarm, and it had bees in it, and they wanted to know what to do. So I told them, actually, it sounds like it's split, like right about there, unfortunately, because they got bees in both halves, and I told them to cover them up and hope for the best. And, but, okay, go back. We have to say right now, or probably a little earlier, a cluster of bees at the bottom of this whole array of combs, and then they just kind of eat their way up. And they're able to do that because, like I said, heat rises and it warms that honey right above them, and they're able to slowly move up. The trick of the whole situation, and we'll show that again, is that they cannot run out of honey until they reach that upper limit. If they run out of honey when they get to the top, there's no place to go, there's no more honey, and they will starve to death. This is what happens actually to most these feral colonies in the trees. They actually don't store enough honey for that first winter, and they die of really a lack of food more than anything else. This would be a typical colony, two-story colony today. The bees are probably still pretty low, and with most of the honey here above it. The size of this cluster will depend on how many frames that they actually encompass. And as you'll see as we progress through the winter, that some of the honey that's out on the outside here will be left because they can't and don't encompass it. Okay? Later in the season, they say they move up and slowly consume that honey. There's probably pollen and honey that they leave behind. Hopefully there's now pollen up here because they are beginning to feed their young or brood, and so they need to have pollen in that stores as well. Okay. And then say by March they will be at the top, and if the temperatures get real cold and they've already reached the upper limit here, of course, again, they will starve even if they have honey in their colony. Often have beekeepers call and say, well, their bees starved, but there was lots of honey in the hive. And I says, well, what do you mean by lots? Well, he says, there was honey down here at the bottom and over here. And I said, yes, but they couldn't get to it.
Did people people ever rotate the frames inward?
Yes, they do. If you got a break in the weather where that's possible, they could do that. Okay. One of the things that beekeepers often do, and this was an experiment we did many years ago. I don't know who took this picture because that's me. We had our colonies in doubles, and then we just made a plastic or a insulated wrap with plastic around it and just wrapped the two together. And it worked pretty well. These are entrances here. The problem with any of these kind of things is the effort and expense of these. So if they're taken care of, they'll last for several years. We actually had an experimental wintering house back here that worked sort of, but not worth, again, the cost and effort. The reason you do this, for two reasons, mostly is to stop the condensation of water. It allows the water vapor from that metabolism honey to escape the hive before it condenses. Because if it hits the top of the hive and condenses, it will just drop out on the cluster and really kill it. One of the things that I do to solve that problem is what I call these winter wedges, and I put these in on either side of the hive, and then you put the inner cover over it, and then of course the outer cover on top of that. And if you push the outer cover forward, there will be an upper entrance actually, because the bees can come out, go down underneath the inner cover or outer cover and fly out. This concept was really mentioned by Langstroth 150 years ago, and that was my kind of takeoff. He actually just put a couple of blocks of wood in there and kept his cover open and lifted them. Okay. That shows them on the hive and with just the inner cover on, and so you have this gap here. And I actually have some spacers here so that when you put the cover down, it always has to stay open in the front. I don't always do that, but that's what those are about. Okay?
Roger,
Yeah.
with that notch that's in the old inner covers, sulfide?
Yes. It does the same, kind of the same thing, yes. In other words, if you had that notch that's right in here, and you just turn the inner cover over, yeah, that works.
There's a couple of Rogers,
Go back. What's that?
little metal things, are they screws? Or
Well, they're just screw eyes, yeah. I just use them as...
to hold the outer cover?
And one of the best things for winter, of course, is lots of snow like we have. I mean, it's actually insulating. The only thing you might have to worry about, and I think you commented about it, was that yesterday was so wet and snowy, it froze actually on the
Well, my hive's tilted forward some, and it froze, but the sun came out enough, just melted enough so it came down,
and dripped on it.
dripped down there, and it actually made an ice dam right across the entrance.
Yeah, right.
I don't have a screen box.
So yeah, and if you don't have an upper entrance, and that's another good reason for an upper entrance, is to have if this gets plugged up with dead bees or ice or snow, they still have a way of getting oxygen, air, or a flight if it turns out warm. I had a friend used to have bees a late friend, he's in the Upper Peninsula, and of course they would covered totally. The whole hive would be covered. Never wrapped because the temperature inside that was always 32. I mean, just almost a perfect wintering house.
What temperature?
Yeah, it was, well, the ice, snow keeps it 32. It would be inside the, yeah. And they wintered very well. He rarely lost bees. This is, of course, a long time ago, but he rarely lost bees because they were always covered with snow. I walked out to them, and he said, "You want to see my bees?" And this was in March, And we walked out, and I said, where are they? And he says, well, you're standing right on top of them. So we were up here somewhere, and we had to dig down to the colonies. And actually, most of them had a kind of a cavity that they had melted out underneath that snow. And sometimes the bees would come out in that cavity, defecate, but most of the time if they did that, they died. Yeah.
Would water do the same thing on the top of the hive, or?
No. Well, maybe, but that would turn to ice, and I mean, it keeps this temperature 32. And mostly what you want is to be around it, and it stops the wind and it stops other things too. I mean, okay, that's all the slides. Good questions? Yeah. Can you? Sure, you could. Yeah. I mean, one of the funnier stories. Many years ago, I had a beekeeper call me, and he said I had a very bad weekend. And I said, "What happened?" He said, "Well, I skied out to my bees, and it took me an hour to uncover the first hive, so I gave up." And I said, "Well, you shouldn't do that." I said, "Snow is good for them. I mean, if it doesn't block the entrance and smother them." I said, "They can breathe through snow. It's the ice that's the problem." So I saw him at A&R week in March, and I said, "How'd your bees do?" And he says, "Only I lost one, the one he had uncovered." And, probably two things. He exposed it, but he also disturbed it probably when he was messing around with it. Steve?
Roger, in January when they start to have brood inside the cluster, but the cluster is still moving up, isn't there a conflict of
Yes.
some of that brood behind?
Good question. There is. And they won't leave brood. So if they go back to, can you go back to about the second, where they had that two-story hive, one of those wintering cluster pictures? That's all right. Either way, that's a good one. Now, let's say they started brood down here, okay? And then the honey was up here. They won't leave it. They'll starve to death. That happened to me, oh gosh, a long time ago now. I had a three-story colony, deep actually, before I switched over to mediums. And the top two were absolutely full of honey. And when I found them, that's exactly where I found them. They were down in the bottom, had started some brood, and wouldn't go across that gap. And I had 120 pounds of honey on a hive and 30,000 bees dead in the bottom. Yes?
This would be a detriment then to 6 5/8 rather than the deeper ones.
No, actually, we find that the 6 5/8, you don't have such a long space between, and so they can get across between frames easier. Actually, Langstroth solved that problem. He took an auger and bored a hole right through late fall so that he had a gap or hole in the center of his frames so that the bees could get from side to side, or frame to frame. You have to do it late because otherwise they'll plug it up with wax. Yeah, Steve?
And since the cluster is probably no more than 3 or 4 frames wide at most, wouldn't that tend to argue with a better wintering, like stacked nukes rather than your standard 10 frame, because you have more honey, more vertical space for them to migrate up to?
Years ago, we used to have 8s, a lot of it. When they're coming back, I noticed that in catalogs now, but we used to have 8 frame instead of 10 frame. And so let's go 50 years ago or 60 years ago, you'd go into a larger beekeeper's yard and there would be some 8 frames and some 10 frames. I mean, just because that happened. And I didn't like it because you couldn't move frames or you couldn't move bodies between, but otherwise they were fine. But if you ask the beekeeper, when did he lose which ones did he lose most? It was always the 10 frames. The 8 frames almost always wintered better. My theory was that the beekeeper tended to put as much honey in the 8s as he did in the 10s, and he had it all vertical, so it solved that that chimney effect that we see that goes in this hive. And like you say, you got these two outer frames that are lost to the system until spring. I mean, they can use it, and as soon as it warms up, they can use that honey and pollen. But it is lost. And so, yeah, 8 frames were better probably for wintering simply because of that. Yeah.
Has anybody been able to get that article that was in Acres and find that material for the moisture board? I think it was melamine or something like that.
I don't know.
But I looked for it at Home Depot and Owasso, and it's all they've got, a thick board that's heavier than Harry. But I think what the gentleman in Illinois was talking about was what we used to call beaver board, or almost like this up here.
Mm-hmm.
He's supposed to send me a picture of it, but so far I haven't got it yet.
Many beekeepers, and I think Mike's one of them, puts a insulation board on the top of his hives, and that again is you have that heat going up there, and because that the water vapor doesn't condense. It gets out before it condenses. There's a question here. Another question. Yeah.
I just never have understood on top bar hives
Yeah.
how the bees move in the winter to honey storage.
Top bar hives are designed for the tropics, unfortunately. That's where they, yeah. I mean, because if you go back another couple, I mean, to that tree, that's what happens in nature, and at least in the temperate region, is this column which is inside the hollow tree. And a top bar hive is just antithetical to that whole system.
But aren't people using top bar hives around here?
Some people, yes. But a lot of them have a top bar hive and then they set super above it for wintering, I think. And it kind of destroys the concept as far as I'm concerned.
What would you say the ideal circumference or whatever would be for something of that nature?
Well, there's no real ideal, okay? Simply because they take what's available. When they've studied swarm size and the cavity that they picked, the bigger swarms pick bigger cavities and smaller swarms pick smaller cavities for that reason. However, over time, they will, if this is a big cavity, this is a big beech tree, you know, with a cavity that's 3 foot around, they'll fill it up. I mean, they literally will fill it up in time if something doesn't happen to it, or disease or something else, lost queen. So I've seen these feral colonies with combs that are 4 foot across, and maybe 3 or 4 feet pendulent down. I mean, they can be really.
Continue to clean it out too, as far as they can get to make.
If the wood is soft, yes.
If there's anything in there.
Yeah, if this is.
That's where my bees started from, is a maple tree.
Yeah, if the pulp in here is soft, they'll just clean it out to make space for them. And if you, I've seen these where this cavity was further down from the opening, say, for example, and there would be 20 years of dead bees down here. I mean, they just kept dropping down there and.
Clean it out.
Huh?
Every spring.
No, they don't.
The tree that I got my bees out originally, they clean that out.
Well, if the bottom,
It was a lightning strike tree, so they had a nice.
okay, yeah. Say if the entrance is down near the bottom here, yeah, they'll clean it out.
They could just keep
Yeah,
cleaning it
yeah.
out.
But I've seen them say it would be years of accumulation here. And, yes.
I have a friend who's had bees in a wood duck box, and they've wintered 3 or 4 years in a row.
Mm-hmm.
And it would seem as if there wouldn't be enough food for them in that kind of box.
Well, we find it, and I think Mike could answer this better than I can, But when they're dealing with these nukes and small overwintering boxes, they find that they don't have enough bees to generate this heat until it gets warmer. So they delay brood rearing until they can. And so we don't get brood rearing maybe until March or even April. But certainly they are able to, with the food that's there, generate enough heat to keep the bees from freezing to death. Yeah, Mike, or Dale.
When they were using 8-frame hives, did they use 3 boxes or 2?
3 usually.
3?
Mm-hmm. But not always, but usually.
So they could chimney up farther.
Mm-hmm. 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 Dale.
The Russian bees do a smaller cluster, but they overwinter better?
The Russians and Carniolans both will have smaller clusters in the winter, and they therefore use less food totally. They use actually, as that graph would show you, they use more food per bee, but actually totally less food.
Generate more heat, so they use more.
Yeah. Mm-hmm. Okay.
Thanks, Roger.